Good morning, everybody, to week 2, day 1 of Computer Science 1. Let me see if I can get the YouTube link working for you guys. 1 second. Is the link to this? Share. Copy the link. And paste. There you go. So you can watch the stream on there. Let's see how many people are streaming this on Discord. Got 41 people streaming on Discord, so it should be fine for now. I woke up, had breakfast. Today's already looking good. That's good. That's good. All right. So let's do this. All right. So our topic for today, you might be able to guess from the textbook readings. The textbook readings are due on Friday, and that is truth tables. So this is something that is probably not the most interesting topic to start the class off with, but it's pretty important, pretty crucial. It'll be on all of the midterms, all the finals, and it'll be used in the critical thinking part, in the computational thinking part, and the social issues part. So it's pretty important. And what we're going to be talking about is the basics of logic. Okay. And so the way that logic works. And so take for example the notion I have a Nissan Altima. All right. Take the sentence. Now, I in this case means me, so we can replace that with Professor Kearney. Okay. Has a Nissan Altima. Okay. So this is a claim about reality. This is a proposition. It is a sentence that contains truth. So what does it mean for something to be true? We're going to have a lecture on that, actually. There's a lot of competing theories of what it means for something to be true. But in this case, this statement here, Professor Kearney has a Nissan Altima, is true if and only if I actually have a Nissan Altima. Okay. Your CSCI 1 professor. Let's put it that way. Okay. So you might ask yourself, well, how do I know if it's true or not? Right? None of you guys have ever met me in person. You know, we're in a pandemic situation right now, and it's you don't know. It is true or false. I'll tell you that. It is true or false. But you guys don't know. Okay? And this is a situation that we'll encounter a lot in real life. You know, the sad reality is that we don't know most things. Do we have class today? Yeah, I'm lecturing. What YouTube live stream is private, you can't see it. Okay. Let me pause this one real fast. Okay. Live stream. Oh, it is private. How did that happen? Alright, edit. Privacy should be save. Okay, try that now. And you should be able to watch on Discord. There's 4 more spots available on Discord. All right. So this is something called a proposition. which is to say a sentence, a statement, maybe, although statement sometimes means the same thing, a statement that carries truth. And in this case, when we mean truth, we mean something that is either true or false. Okay, so this statement here, your CSCI 1 professor has a Nissan Altima, that's either true or false. Okay, this is a claim about reality, and so we're going to talk about different theories of truth and stuff like that. But in this case, we'll just stick to the simplest basics. And this sentence here, your CSCI 1 professor has a Nissan Altima, is true if I do actually have a Nissan Altima, if I do own one. And it is false if I do not. Okay? So how would you guys think about going about determining if this statement were to be true or false? How would you assess the truth of this statement? What do you guys think? You've never met me. You currently don't know the truth value. How would you assess it? You can guess. Like, why would he mention a Nissan Altima if he doesn't have one? I don't know. Checking the DMV records. You can ask me. Yeah. Yeah, okay. So let's say I tell you it's true. Does that help? I'm smiling. Does that undermine the witness statement that I just made there? Could be lying. How do you know if it's true? You can check the DMV records, but at the same time, maybe the DMV records show that I have a Nissan Altima, but maybe it's been stolen. Maybe I don't actually have one at this moment. It's been, in fact, I haven't checked outside. It could be gone. I don't know. I park on the street in Fresno, which is always a risky thing. If it's true, you'd like to see proof with, like, holding keys, official records for it to be true. Huh, interesting. Yeah, I'm not showing my DMV records, but all right. Here is the keys of a Nissan. It's a key fob for a Nissan. You can see the little Nissan logo right there. Would that increase your confidence that I have a Nissan Altima? It doesn't say Altima on it. It does say Nissan. So, what do you guys think? Are you more confident that I have a Nissan Altima now? Technically, I'd still own it. That's true. But I have one. I didn't say own. I say I have one. Excuse me. So, if you physically see me driving a Nissan Altima, yeah, seeing is believing, right? So, evidence is that which increases terrible handwriting is that which increases our confidence in a proposition. Okay. Doesn't have to be proof. In fact, proof is like overwhelming confidence. So I just showed you a key fob that had Nissan on it. Doesn't say Nissan Altima, but it seems unlikely that I would have that just randomly if I drove like a Ford, right? Show your car on the stream. Is this the Schrodinger's car dilemma? No, I'm trying to get you guys to think about truth and things like that. And so, because as I said, we're gonna be talking about these kinds of things all semester long. So, what does it mean for something to be evidence? What does it mean for something to be a proposition? What does it mean for something to be proof? Okay, and then we'll do truth tables because truth tables are going to be all over the place. So, what does it mean for something to be had? I don't know. What does is mean? Right? What is the 370Z? Yeah. I was actually driving behind one yesterday, so I was close to a 370Z. So the fact that I held up a Nissan Altima, or sorry, a Nissan key fob, is evidence, perhaps, for the statement that your professor has a Nissan Altima. And I've told you, I just told you, I do have a Nissan Altima. So that would also be evidence, right? If I tell you I have a Nissan Altima, well, I would be in a position to know, right? It's my car. So I have C tons of 350Zs and 370Zs at my job. Maybe you can come through with your Altima. What kind of job do you do? What does it mean for something to be have? Yeah, like in my possession currently. I don't know. All right, and so proof is convincing evidence. Right. And so when you say prove it, that means give me enough evidence that I will believe you, right? And or kind of overwhelming evidence, more than just I'll believe you. Just like it's established beyond a reasonable doubt. So maybe if I showed you my DMV records, which I'm not going to do, if I showed you my car outside, which probably could, probably could do it, but it'd be a little awkward. I love your car, Professor. Thank you. You get an automatic A in this class. So, do you guys understand? And so I presented, I gave you a proposition, and I presented some evidence for it. I gave you a witness statement. I own a Nissan Altima. I showed you, this, and I could show you my DMV records and things like that. And eventually, at a certain point, you'd be like, all right, I'm convinced he has a Nissan Altima. You showed me a picture. It could just be some random car outside, right? Because none of these, there's always a chance you're going to be wrong. And this is something that people have a hard time struggling with, which is that, you could be wrong, right? So, it's actually, ironically, one of the greatest fears of people online is that they'll be shown to be wrong, And in all honesty, it's like you should always be open to the fact that you could be wrong. Like I could just be completely BSing you right now, right? To make a point. The fact that I'm smiling, might make you question all of this evidence and be like, all right, maybe he just looked out his window and saw that there's an Altima parked out there. And I don't know about the key fob, but yeah. Does anyone wonder if he's been pulled over as a DUI? I don't think I've ever been pulled over in an Altima. Last time I got pulled over for a speeding ticket would have been 2005, probably like that. Something like that. I used to drive back and forth between San Francisco and San Diego, couple times a month, which is a lot of driving, and so I tended to speed because that drive was terrible. The drive between San Francisco and San Diego was terrible, and it's terrible to do that regularly for work. And so I tended to speed, and I did get pulled over a few times. In this class, you'll learn not to trust anything or everything. Good. Doubt. I'm instilling doubt in my students. Don't trust me. I'm not actually a real professor. I'm a computer-generated deepfake. I'm actually sleeping right now. The AI is generating this. Don't tell me you stole those keys from your neighbors. So how many people here, just out of curiosity, how many people here are convinced? Have I given you guys proof that I own a Nissan Altima? I'm just curious. Have I given you enough convincing evidence? I will swear, in fact, I'll give you more than a statement. I will, state with certainty, I own a Nissan Altima. And I've shown you the key fob. Is that enough? Is that proof for you guys? Or do you want to see a picture of my car? It could just be me standing next to a random car. More evidence, please. Doubt. Pressing the doubt button. Nice. Very nice. Can't tell how far you'd like to go with trolls yet. Convince you on a Nissan. Not sure if it's an Altima. Okay. Good. Do I actually have a picture of it available? Where would I have a picture of my car? I don't take pictures of my car. Yeah, sorry. That's about all I have ready right now. Maybe next class. We'll see. Okay. So we'll just leave it at that. That is that. Now, what if I made a little more interesting statement, right? Your professor owns a Nissan Altima, or he doesn't. What do you guys think? Is this statement true or false? True or... Let's not turn the R into an F. Is this statement true or false? Either your professor owns an Altima, or he doesn't. Yeah, that's true. Good. Right? It's basically the case that, well, if I don't own a... So, or. Okay? And so an or statement is true. It's true if either side is true. Okay? And so over here, your professor owns a Nissan is one side of it, or he doesn't is the other side. These two things are logical negations of each other. And so if this side is true, this side is false, and therefore the whole thing is true. Or this side is false, this side is true, and then the whole thing is true. An or statement is true if either side is true. And in this case, one of the sides must be true because they're logical opposites. When one is true, the other is false. When one is false, the other is true. Either way, one of the two sides is going to be true. Therefore, this whole statement is what's called a tautology. A tautology is a statement that must logically always be true. And if we learn about fuzzy logic, we'll learn more complicated things like this. But this is good as a good starting place. 75% chance of it being true, yeah. So with fuzzy logic, you can actually have truth values that are between true and false. And so, worst case scenario, that could be half true. All right. Now let's talk about an and statement. So, your prof owns an Altima, and he has a purple shirt on. What do you guys think? True or false? Your professor owns an Altima and he has a purple shirt on. Unless you're colorblind. See, here's the thing. How do you know that the camera is supplying you the correct color of this shirt? Sure, it looks dark green or blue, you can't tell, right? You've got video footage right now of my shirt. First day here, have you missed anything important? I think it's probably false. Interesting. 75% chance of it being false. In this case, this is a true statement. I do both own an Altima and I'm wearing a purple shirt right now. It doesn't look like it on the video. This is actually a very dark purple or indigo shirt. So the camera is actually filtering out the color. It's white balancing the screen out, and so the video footage is actually lying to you right now. And this is actually, it's very hard to tell, but it's actually a very dark purple. It's actually very close to black, like a navy kind of. So you can't even trust what you see with your own eyes. Doubt. everything. And a nice rainbow glitter font. So, yeah, there will be a certain amount of this during this class. So yeah, it is actually the case on an Ultima, and I do have a dark purple shirt on right now. You're not blind. It's not you. It is actually the camera. That's why I was double checking this real fast. Yeah, it's actually the camera that is not displaying it properly. Your life is a lie. Then you've been deceived. Yes, there will be a fair bit of that in this class. Stealth and deception. No, I'm kidding. Okay. So we're going to talk about something called a truth table. A truth table. And a truth table is a way for people that work with logic to kind of work out more complicated truth claims. And so your most basic truth table looks something like this. So if you've got X could be either true or it could be false, right? And so the only thing we can do just with X is to not it, right? So if I use logic, there's logical notation. There's at least 3 different ways you can say not X. So let's say X. Let's say X is your professor is wearing purple. Okay. And so not X, which is the same thing as saying your prof is not wearing purple. I'm just scribbling that at this point. We could write this either as not X like that. We can write it as not X like that. We can write it as not X like that. What else? Tilde X, not X like that. So it's one of the most annoying things when dealing with logic and math in general is the terminology and the symbolism, the symbols used and things like that differ. And they also a lot of times look like garbage. In this case, I'm going to use exclamation mark, not X, because this is computer science, and in computer science we use exclamation mark to mean not. In the textbook, I believe they use the little handgun thing as the logical negation character. Okay, so your prof is wearing purple, your prof is not wearing purple. So if this is true, then this one's false, and if this one's true, this one's false. And so what we do is we write down the truth table like that. So if X is true, then not X is false. If X is false, then not X is true. You guys with me so far? Join the class voice channel. You're still lost. So a truth table is just a way of saying if the truth, this X means kind of like the truth of this statement here. Okay. So is it true that I'm wearing purple? Yes. Okay. Then the truth that I am not wearing purple is false. Does that make sense, Mata? So if the truth of your professor is wearing purple is in fact true, then the truth of you're not X, your professor is not wearing purple is false. You guys with me so far? So this is just a little handy. It's like a flashcard. You can look at it and be like, okay, well, normally we don't write down something so simple, but this is the easiest truth table. Yeah, this is actually a very dark purple that is not coming through on the screen. Okay. So let's talk about the other 2 things. We had or right here. Your professor owns an Ultima, or he doesn't. Okay. So how would we write this as a truth table? Let's find out. So we have X, not X. true, false, false, true. And then how do we write down or of x and not x, or you can say, I believe your textbook uses the logical conjunction operator. And so in order to write down or, you can either just say or of two things, or you can say x ORed with not x, or you can say x logical conjunction with not x. What are the other ways of doing it? X plus not x is another way of writing down or. Or you just write down or. X, x ORed with not x is another way of doing it. Like I said, in logic and in math, people just love using symbols, and the symbols are not consistent. So, the or, an or statement is true if either one side or the other or both are true. So in this case, this or statement here will be true if either of these two things is true. And what you do in a truth table is you kind of go across the rows when you fill them out. So you kind of go across the rows, and so you say, okay, x. Let's assume that x is true. That means that x not x is false, and so x ORed with not x must be true because one of these two sides is true. Either the left side's true or the right side's true. In this case, the left side's true. Therefore, the result is true. In this case, you go across. You start with x is equal to false, and not x must be true. X ORed with not x must be true because the right side in this case is true. And so this is a very simple truth table, and you wouldn't bother with this in most cases because you guys figured this out just by looking at it, right? You don't need to sit down and really write it out, right? It's like if I asked you to add 2 plus 2 and show your work, you're like 2 plus 2 is 4. No, show your work. 1, 2, 3, 4. And so let's do a slightly more complicated example with or. Okay, so let's say x is a student in this class owns a horse, and y is a student in this class owns a snake. Then x ORed with y in English, x ORed with y, x ORed with y. This is the computer science way of writing it. The textbook would say x ORed with y like this. Same thing, just different terminology. X ORed with y would be, in English, a student in this class what? Convert x ORed with y to English, please, for me on chat. So if x is a student in this class owns a horse, and y is a student in this class owns a snake, what is x ORed with y? A student in this class owns what? A horse or a snake. Yeah, very good. A horse. And no, I wouldn't say a student in this class owns a horse or a snake. I would say a student in this class owns a horse, or a student in this class owns a snake. Probably works out to be the same in this case, but yeah, sure. We'll just put it down that way for less writing. Or a snake. Because we could have two different students, right? But in this case, it works out the same way. Okay, so let's find out. Let's do a slightly more complicated truth table. In this case, we have x and y as our starting point. and we've got x ORed with y as our output. And so what you do when you do a truth table is you start off by filling out all the possible values for the input. Okay, so the possible combinations of output is this: true, 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 false, false, true, false, false. This is every combination of setup, right? In this case, this means a student in the class has a horse and a snake. Some student in this class has a horse but not a snake. Some student in this class has a snake but not a horse. And in this case, nobody in the class has either a horse or a snake. Okay? And so that's the input. That's how you start a truth table. You start off by trying you write down every possible combination, and then you figure out what the results would be. You figure out what the results would be for each combination of input. Okay. And so in this case, OR is true, or this is OR. The double vertical bars are OR in computer science terminology. OR is true if either side of these is true. So in which case will this statement, a student in this class owns a horse or a snake, when will this be false? It'll be true in most circumstances. But when will it be false in English? When will it be false? When nobody in the class owns what? When nobody in the class don't own both. When nobody in the class owns a horse and nobody in the class owns a snake, right? So in that case, this one. That's the only time that will be false. In the other cases, will be true. Okay, so let's actually just take a poll. I know somebody said they owned a horse in real life. Does anybody here own a snake? Just out of curiosity. I'm kind of curious now. I have no way of verifying this, right? I'm not going to ask you to bring a snake to my house, but I'll take your word for it. Your sister owns one. Yeah, close, but no, I'm not going to allow that. Somebody owns 2 horses. Okay, all right. Yeah. Be tight though. 2 horses. Okay. Well, so far so good. Yeah, it looks like at least 3 people that they would eat this snake in my house. It looks like at least 3 people do the snakes in your backyard count? I don't know. I'd go with you don't own it. I would say you don't own it. That's funny though. I used to live on a canyon, and snakes were a constant, nuisance. Okay, so I'd be out jogging, and I would see like a tree branch across the sidewalk, and I'd just leap over it because I didn't trust it to not be a snake. So it looks like we're in this circumstance here. Do you guys see that? So you set up your truth table in advance, right? You set up your truth table in advance. What are all the different possible scenarios we could deal with? Nobody has a horse. Somebody has a horse. Nobody has a snake. Somebody has a snake. These are the 4 possibilities, right? And so it turns out in real life, this is our circumstance, and so this statement is true. Because somebody at least three people in this class own a horse. Therefore, the statement that somebody in this class owns a horse or they own a snake is true. Are you guys with me on this? This learning how to do this truth table thing, this will be on both of your midterms and it'll be on your final. It's a very important skill to have, and we're starting really simple, but they do get more complicated. Okay. So, and you use these when you program. You use these when you engage in argumentation with people. You use them, just in general. Having a good understanding of logic is actually really fundamental to kind of everything we're going to do in this class, and that's why we're starting with it. Also because it's your first textbook reading, and I wanted to kind of lecture on it because last semester, even though we went over it a few times, some students, like even on the final, couldn't do this, which is kind of embarrassing to me. So, yeah, let's talk about and then. So let's do the truth table for and. Your professor owns an Ultima and has a purple t-shirt on. Okay. So in this case, this part is X. Your professor owns an Altima. This part is Y. He has a purple shirt on. And let's draw out the truth table. So there's 4 possibilities. And is written, and is written either like that, or you can say X and Y using double ampersands. You can say X and Y using the caret. What else? X times Y is used sometimes as well. Yeah, let's just stick with that for now. Yeah, so like I said, there's a lot of different kinds of terminology. I'm a computer science person, so I use the computer science terminology. So we're going to go with X anded with Y. The 4 possibilities are true, 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 false, false, true, false, false. And so prior to even looking at the evidence, you can sit there and fill out, you can fill out this little cheat sheet for you, right? And so an and is only true if both sides are true. So an and is this statement here, your professor owns an Altima and he has a purple shirt on right now. This is only true if I both own an Altima and have a purple shirt on right now. Okay? So, right? And so the only scenario in which the result of that and will be true is if both sides are true. If both X is true and Y is true. In every other circumstance, that statement would be false. Okay, so if I'm not wearing a purple shirt right now, then this whole thing would be false because I am not wearing a purple shirt and having an Altima. I could have an Altima, I might not. But it doesn't matter. If I'm not wearing a purple shirt, the whole thing's false. And likewise, if I don't have an Altima, it doesn't matter if I have a purple shirt on or not right now. The whole thing's going to be false. Which notation will be on exams and quizzes? I typically use the computer science notation. So I typically use and, or, and not. Because then you're going to have less friction, mental friction when you take computer science classes, because this is what we use. But the textbook uses that, and that. Or, sorry, I did this backwards. Conjunction. Oh, did I call I called it backwards, I'm sorry. That's conjunction, that's disjunction, and that's negation. I think I called that conjunction, my bad, earlier. This is conjunction, which is and, disjunction, and negation are the names of the symbols, kind of. And or not. And or not. You'll see that in the textbook. For the midterms, I do this, so that you guys get used to it. So what if, so with and if both sides is true, then it's true, right? Yes. If both sides is true, if both X, if I both have an Altima and have a purple shirt on, then this entire statement, X and Y, is true. And that's what this truth table is showing us, right? The truth table is showing us that if both I have an Altima and have a purple shirt on, then I have a purple shirt on and have an Altima is true. Okay. Negation is equal to the exclamation mark. Yeah, that's correct. So this is negation. This is conjunction. No, sorry. Disjunction. I don't know why I keep saying that backwards today. Disjunction, conjunction. Yeah, the exclamation mark means not in computer science. We just read that as not. And or not. And or not. And then if you're in electrical engineering, electrical engineers do and or what's not? A bar above it is not. So you'd write like bar X to mean not X. So if you guys go into electrical engineering, computer engineering, these multiply, because if you look at it, right? Suppose true is 1 and false is 0. 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. Okay, so that's why electrical engineers use multiply instead of and. And then where did the or thing go? It's down. And then they use addition for this because 1 plus 1 is 10. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. And so only 0 plus 0 is 0 gives you 0 as the output. So the other three are true. And so electrical engineers note that the and, or, and not, and works like multiplying, or works like adding, and not is, I don't know, they just draw a bar over it for some reason. Like I said, there's many competing sets of notation, and it's just kind of annoying, right? So you'll see this mostly in philosophy. The caret, the little v, that's like a little v. It's not like a full-size v, it's like a little v. And the little finger gun, that's used in philosophy and logic. This is used in computer science, the double ampersand, double vertical. And electrical engineering uses plus stuff. Okay. All right, so let's show you guys a more interesting example. These are the basics, though. So let's see here. I don't want to write out the whole sentence again. Let's say X is students in the class own a horse. Y is professor owns an Altima. And Z is somebody give me some sort of proposition, something that could be true or false. As the textbook notes, not every sentence you can make in English is a proposition. For example, if I tell you you should drink, or let's see, do your homework, that's not a proposition, right? It's a command, right? So if I order you to do your homework, which is probably a good idea, it's not true or false. Or, if I say that Taylor Swift is the greatest musician to have lived of all time, that's an opinion, right? That's not a proposition. It's just, it sounds like it should be true or false, and you could probably express it in such a way that was true or false, like she sold more records or, something like that. But if you just say that, Hawaiian pizza is the best tasting pizza, that's just an opinion. It's not really true or false. You guys with me? A student owns an Android phone. It is sunny. Yeah, that's an interesting one. Yeah, let's go with that. It is sunny right now. Okay, so let's make a truth table for X ended with Y ORed with not Z. What? Okay, so in English, this sentence would be, it is true that a student in this class owns a horse, and either I own an Altima, or it is not sunny right now. That's English. Can you add in can to make it a true or false? True or false? But can Taylor Swift can be the greatest musician? I don't know. You can do your homework right now. Can do your homework right now, I guess, would be a proposition. Yeah. Basically, a proposition is something that can be true or false. It bears truth. So, like, I have a guitar pick in my hand. Yeah. Right. That's a statement that's true or false. Right? You should have a guitar pick in your hand is not. That's not true or false. It sounds very similar. I have a guitar pick in my hand. You should have a guitar pick in your hand. And statements like that where you should do something or you're expressing an opinion, things like that, those aren't really propositions. Now, well, we only got 3 minutes left. But one thing that might bake your noodle a little bit is murder is wrong. Is that true or false? Murder is wrong. Think about that while I'm drawing out this truth table. Murder is wrong. Is that a proposition? Does that contain truth? Or is it an opinion? Is it a fact? Is it Does it make a claim about reality, or is it different somehow? True, 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 true. Didn't draw that T very well. True, 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 false, true, false, true, 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 false, false. Murder can sometimes be justified. Okay. It's more of an opinion. Okay. I mean, murder is the unlawful killing of someone, right? That's the definition of murder. It's not like you know, if you kill somebody in self-defense, that's not murder, right? So false, true, false, 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 true, and finally false, false, false. Now you might notice that there are now 8 rows here. And that's one of the annoying things about truth tables, is that as the number of inputs goes up, the possibilities doubles every time. So if I had 4 inputs, 4 different statements, then I would have 16 different rows here. Yeah. Okay. So with a truth table, you typically break it down one step at a time. So we can look at y ORed with not z first, and we'll get to the whole thing later. So in what circumstances is y ORed with not z true? So that's true if either y is true or if z is false. So this is how you truth table, and these kinds of questions will be on every one of your midterms and your final. Okay. So in English, x ANDed with y or not z in English is somebody in the class owns a horse, and somebody in the class owns a horse. Let me scroll this a little bit for you guys so you can see it. Somebody in the class owns a horse, and either Iona Ultima or it's not sunny right now. So we're just going to take the Iona and Ultima or it's not sunny right now part of it, and then we'll proceed from there. So this part here is true it's true if either y is true or z is false. Do you guys see that? So in this case, y is true, so the output's true. Y is true, the output's true. In this case, y is false and z is true, so yeah, it doesn't work, it's false. And then in this case, z is false, the output is true. Y is true, y is true, false, and true. Okay, so you can see that this little part here is true in most circumstances, except for when the only time it's false is when I do not own an Ultima and it is sunny outside. Okay. And now let's do the final row. And that is x ANDed with y ORed with not z. So we've got this column here, which has figured out this part of it, right? And then we've got x. And so we need to look at the x column, and we need to look at the y ORed with not z column. And this is only going to be true. The whole thing is going to be true. The whole thing's going to be true if x is true and if this this column here is true. And so this is how truth tables work. You start with every possible input, and then you just kind of work your way to the right and figure out what the ultimate truth is. And so in this case, this will be true because x is true, right? There's a t there, and there's a t there. And so in that case, the output, the whole thing is true. So it is true because it is I have what is it? Somebody in the class owns a horse, and because I own an Ultima. So the output's true there. Here we have true and true. That's true also. True and false is false. So in this case, somebody in the class does have a horse, but I neither have a Ultima and it is not sunny outside. Coming down here, true and true is true. And then all of these will be false, because in this case, in these 4 rows, see that all of these are lead off with a false right here. So that means nobody that if these are false, that means nobody in the class has a horse. And so the overall statement of somebody in the class has a horse and all this other stuff is going to be false. So the end result is there are 3 circumstances. There are 3 circumstances in which this statement is true. It's true when somebody in the class owns a horse, and I have an Ultima, and it's sunny. Somebody in the class owns a horse, and I have an Ultima, and it's not sunny. Somebody in the class owns a horse, I don't own an Ultima, and it is not sunny outside. These are the 3 times when this thing will be true. And programmers use these things all the time, because if you're making a sentry gun, and the sentry gun's going to shoot, at people, you might program very complicated rules into the sentry gun, like shoot if the person's carrying a gun, and they are not carrying an ID badge, and they're tagged on the other team or something like that, right? And this could be a sentry gun in real life, or it could be a sentry gun in a video game. And it's based on a person's opinion. Yeah, it's a really interesting question to go back to what I asked you guys. Is murder evil? Is that a fact, or is it is it a proposition? Is it something that bears truth? Can it be true that murder is evil, that murder is wrong? And so that's something that philosophers debate to this day, right? Is it truth bearing? Or is it just nonsense? Is it just like your personal opinion? Like, I'm revulsed by murder, therefore it's wrong. It's just a personal opinion. Like, some people don't like pineapple on their pizzas, right? Okay, so anyway, this is the upshot, and this is what you guys will have to produce for your midterms and for your final. And so the first homework is due, the textbook reading is due on Friday, and so make sure you go through the homework, the textbook assignment, and make sure you can work through the truth tables. And there's lots of practice on that. There's supplemental work that you don't have to give to me. You can just work it out on your own. It gives you the answers, I believe. Oh. Well, if you're Liam Neeson, then it's not wrong. Okay. So that was a brief introduction to truth and to truth tables, and we'll pick this up again on Wednesday. And one of these days, I was lying to you about the shirt. The shirt's actually black, or is it? I don't know. You can kind of see the color now, I think. I don't know. What do you think? It's not black, I'll tell you that. The truth is out there. And on that note, I will end the stream. See you guys.